Welcome everyone to Techaway, where we invite GovTechies of various disciplines and talk about all things tech over bubble tea.
Hi, I'm Yokmi. I think we're all from GDS. So I'm looking after the Apex and the Nectar products in GDS.
Hi, I'm Ishan. So basically, I'm the tech lead for the Nectar team.
Hi, I'm Jennifer. I'm the DevOps engineer of the Ship team.
So I'm Hunter. I'm a bit of the odd one out, other than being the young mo in the room, but also I'm actually part of a group called Code.
And I'm Samuel, your host for this session. I also work with the GDS team. I help out with various concerns and issues in the team. So yeah, what does it mean to build platforms for the government? Can anyone tell me?
So probably let me just start off with Apex, okay? Because Apex essentially is API gateway for the whole of government use, and also for agencies, okay, to be able to share data among themselves, right? So in order to build a government system, especially for this kind of large scale enterprise, I would think there are some major considerations we need to take into account. One, of course, is compliance and security are a big thing in the government. So of course, that is the main thing we need to consider when we build the platform, because because we have so many agencies in Singapore and they're all residing in every part of Singapore. So we need to ensure that the security measures are in place, okay, to enable the agencies to actually share the data securely. And the second major considerations to take into account when building such a large-scale platform is on the scalability of the platform, because we need to be able to scale the platform to handle, especially like sudden surge in transaction volume, especially like when there are special events. Like for example, minister giving a speech, and then the next day we'll expect loads of transactions coming in. And the third thing, usually for this kind of enterprise scale applications in the government, is to be able to cater to multi-tenancy. Yes, because especially agencies are everywhere in Singapore, so we need to be able to provide this kind of platform for them to exchange data in a secure manner, and also to ensure that data is not tampered with.
So you mentioned that there are certain security policies that we need to adhere to. There's also a need to enable government systems to scale up. And that's the kind of platforms we build and provide. What would you say is different about government platforms? How is it different from
enterprise?
Other enterprise platforms?
Okay, I would think basically they are about the same. Okay, so probably the only difference is the target audience that we're looking at. But security compliance is essentially similar in the enterprise platforms.
What about you, Yixing? Can you tell us more about the Nectar platform?
Okay, so Nectar platform is similar, as in it's a whole government container hosting platform. So we actually need to look into how do we secure the platform for hosting purposes. In this case, we only handling containers itself, and because policy is quite extensive in the government, and we have to handle a lot of different use cases. So at times we need to actually think about, is it okay, or do we allow people to do things certain ways, which actually restrict the usage of the platform itself. So we have to weigh the pros and cons. But I believe pros and cons is always there, regardless of which path you choose. So that's the difficulty in creating a platform in terms of Nectar itself.
So containers is a relatively newish technology. It's been around for a while, but what's an example of one of the security considerations we have to make when hosting containers for government agencies?
Okay, one very, very simple one, just as an example, is that regardless of is it containers or VMs, services should not run as root.
Oh yeah,
but
sure.
Because education-wise, certain knowledge is lacking in terms of certain vendors, they actually want to request for root access, which is actually not really a good thing, not just in containers. So this kind of security aspect actually is more on the educational purpose, so that we need to actually let them know root access should not be just given anyhow one.
So in general, it's more of a good practice, not to have this kind of a super user access.
So the platform helps enforce the desired workflow to enforce security policies.
Yes, we aim to achieve that.
Okay.
Yes.
Okay. Jennifer, what about SHIP? How does it help government agencies scale up their development?
Okay, so for SHIP, as I say, we are the CI/CD pipeline, so which is like continuous integration and continuous deployment. So SHIP is a pipeline which like help government developers to test, build, and also scanning of libraries for vulnerabilities. So that like because we need to be on a secure pipeline and all this, so that all the agency can use the common pipeline to like also share services and all this. So this enables like developers to like build and test so that we can deploy to the different environment faster and more stable. And we also do like the shift left methodology, which is also like we need to test it earlier so we can detect any problems at the early stage. So anything we can solve it, resolve it as early as possible, and we can have a more stable code to deploy to other environments.
So the SHIP platform allows government developers to do all of that.
Yes.
Okay, that's interesting. Hunter, any thoughts of these existing platforms and how they can be improved?
Well, I think it's a really exciting thing that we're doing here is that we're able to build out this common set of platforms that really help agencies deliver services to citizens, more quickly. I mean, it's one thing for everyone to be doing their own thing and to be building out, different things. Now, obviously, we have policy and compliance requirements. Now, everyone can go off and do that themselves, but if they do, it's very, very expensive to do. So, common platforms help this approach of making everything a lot easier, a lot faster, and a lot safer. So, I think it's really great to see that these sorts of things have been in place for quite a while. We've got quite an established process and practice that goes around it. And now we're looking at taking these things into the cloud to get even more agility and more ability to scale and service, both the needs of the agencies and help them deliver for the citizens. So it's actually, having a really great and strong impact. So it's really quite exciting to see.
Infrastructure as code. Can anyone tell me what is it and how we're using it in government?
Can I correct that? I will say everything as code. Everything as code is the best way to go.
Because we use the term IAC so often in government, we actually have blacklisted from using the term.
Is it?
Yeah, we've actually sort of internally as a joke, we don't use IAC, we call it automation.
Then how about everything as code?
Okay, everything is called EAC.
EAC.
It sounds like a brand or something. Okay, it's okay.
It's a buzzword.
Okay.
How are you using it within GovTech? What are we doing with it?
So I'll start with my portion. So basically, everything as code includes, like what I mentioned, infrastructure.
Okay.
But also includes like, for example, the policy and the configuration. Actually, configuration is part of infrastructure, but everything includes the application, the service, to the definitions. So it's really everything as much as possible as code, even documentation. So documentation, I believe, is one of the more difficult one to tackle because normally documentation need to write a lot of paragraphs, which is not code.
Yeah, a lot of technical writing there.
Yeah.
Yes.
So that part is a bit, I'm still exploring it.
So do you eat, sleep, and dream about IAC all the time or EAC all the time?
Whenever I think about the decision making process, right, I will think about is it capable in code?
Okay.
Yeah. Rather than just thinking about implementing it, I will think is it capable to be done in code?
I see.
Yeah.
That's how what software engineer does, right? We dream up the capability, what we want to achieve, what functionality we want to achieve, and we try to express that in the language of our choice. So that's pretty much what we do as software engineers. Is it possible in any code, any tool, right? That's especially true with CI/CD platforms, right? Can I build this? Can I package it? Can I pre-configure my Java VM? Can I pre-configure my container, so on and so forth, right?
Yeah, like for SHIP, like we also do like same as him, like everything as code, we try to automate everything as much as possible. Because like if we every time we want to create new resources or change some configuration and all this, which is like easier in code than documentation because code explains everything faster than you already have the right paragraph of documentations. Yeah, and also we develop all the operation also as code. So like which is also easier for us and also for operation. Like if anything went down and everything, if we want to like, spin out new resources or all this, it's like everything is already codified and tested.
It allows us to sleep better at night.
Yes.
That's very important. And it allows people to gain the knowledge faster
Yes.
rather than full on hands off. Yeah. Full on handover.
Oh yeah.
Yeah. So basically
yeah.
the knowledge transfer process is shortened.
So if I want to take over a project from you, I can just look at your code rather than look through a 100-page paragraph of 100 grave
Basically,
documentation.
normally, from what I understand, is that you need to sit together and then explain.
That's the best way of knowledge transfer. Yeah.
Yes, but with this, everything as code, right? It's easier to, let's say, you point to a certain piece of code, and then tell them that this particular piece of code is actually related to this and how do they relation each other, rather than page by page of documentation, and then tell them that this is this, this is that, but there's no direct reference to the service or the object itself. Yeah.
It all sounds a little bit like magic. Is there anything it can't do?
Configure Windows GUIs.
Oh, I don't know. Isn't that what's like robotic process automations called? Or
It's possible with
I
the
suppose with very, very sophisticated macros.
yes,
Very, very, very sophisticated macros. Yeah. Okay.
and they are supporting Unix now, so it's fine.
Oh, that's true. That's true. Thank God for the new .NET, right? Okay, I'm going to take a question from this bag, and let's see what's in here. Hold on.
is it
Is
lunch?
it this now?
Is it lunch? No, it's a
Lunchbox.
series of questions. Let's see, it's like
Series
pick out a
of questions.
lottery winner.
Bingo. Oh,
Wow,
Looks pretty long.
when family members ask you what your job is about, how do you explain it to them?
wow.
Walao, right? Wow.
Tricky question.
It's a very simple. It's a standard answer. 做电脑的.
Pretty much what I tell my mother too. It's like,
Do you understand that?
You understand that?
Sorry?
You were saying 做电脑的
Yeah.
in
Kind of, yeah.
Okay.
Direct translation. Do you know what's the direct translation?
No, what is
we
it?
build computer systems.
No, not just. It's not computer system. It's like something to do with computers.
Yeah, something
Oh,
to do
okay.
with
Yeah.
Anything to do with computers.
Yeah.
That's generally my answer too, except in English.
so, any other answers other than building computer systems?
Okay, how I normally explain to my kids, it's like, mommy, where are you going? What do you do in the office? So the way I phrase it, because they love to play with Lego.
Okay.
Yes, so I will explain in such a way that it's really similar to what they are building for Lego. So it's like blocks, when they build blocks. So I tell them that when you build blocks, okay, I also build similar blocks, but it's more for for users to use as a system as a whole, right?
Actually, there's one event when I explained to my friend
Yeah.
about what I do in the government, because GovTech, and then they said,
Yeah.
normally before I joined GovTech, I'm actually not really into government jobs.
Yep. Okay. Yeah. The transition from regular software engineer to GovTech engineer is a bit of a
Yes.
transition.
So at that point of time, I explained to them that it's because what this role does. So I explained that they don't know technology. So I explained as a role as in all engineers, I will call them chef.
Okay.
So what I do is I build the pans and the stove for them.
Wow. Okay.
That's not being a chef. That's a blacksmith.
No, as in normal engineers chef.
Ah.
So as from a chef, I convert to building stove and pans for them.
So you're the subject matter expert for building the tools that chefs use.
Yes.
Right.
Yeah.
Oh, that's a really interesting way of looking at it.
Yeah.
If my parents ask me, I always told them like something related to IT or computer stuff. But if I explain to like friends or like similar ages who like understand IT, then I will like just say, okay, so ours is just like a platform, because we have software engineer do coding and all this, so we help them to like improve the process faster and build it automatically for them. That's what I told them. So sometimes for non-IT people, sometimes they will like have to think for a while like what you already do and all this. Yeah. If I talk to my ex-colleagues and all this, they will be easier for them to understand.
I think times have changed in the sense that people are more aware of what's happening out there. People are more inclined towards the more high tech stuff. So it's not like last time doing my time wrong back. It's like computer science is something that is like, oh, okay, so you build computer, you need
The
We don't build low-level systems.
Yeah.
yes, exactly.
But
So
it
it's-
adds to the mysticism sometimes, you just tell people, oh, I just do mysterious things and you will never understand.
like what
Like in the movies where they have the
That's
screen, the green words keep moving up.
Yes.
For
yes.
That's
90
true.
people, they will say like alien language to them.
I once sort of described what I did as being a bit like the weatherman, but that just confused everyone even further because they thought I was working for, NEA or the weather organization or something. It's like, no. And then it's like I help, the government use the cloud. So that didn't really help much either still, but it was a little bit closer.
And talking about cloud,
Yeah.
confuse people even more.
Oh, no. So yeah, I skipped that analogy completely. It went over like
Most of the time, I just tell people that I build government services, government systems, and then I start talking about how we do it in government. What are our requirements? Who do we need to negotiate with? Who do we need to talk to in order to build the government system? And that is more interesting than programming itself, I think.
Okay.
So what are the security policies you need to look at? What are the high availability concerns that you need to be worried about? Like, what if Singapore gets bombed, right? Remember, that's a very common consideration that we can make. And then after that, you have to decide, if you're scared that we're bombed, build a second system that does the same thing and do load balancing between the two. Then I start talking about high availability, all the stuff that is required to build this complex system. And my friends look at me like I'm crazy.
That happens.
Mad technologies.
That's pretty much what it is. So what are we doing differently on the cloud? Can anyone suggest anything? Well, when moving these platforms to the cloud, what are we doing differently? Nobody?
So I think it gives us a point where we can fundamentally rethink how we're delivering these services. Now, in a traditional environment, we've been working, on-prem. We've had to be dealing with servers. We're having to be dealing with, potentially, configuration and setup of all of those things. So, delivering value is there's a lot more steps to go through. So, as we move to the cloud, we get the point to sort of think and reanalyze what we're actually doing. I mean, fundamentally, the ideas that we've talked about around sort of API gateways, container management, and CI/CD is, fundamentally the same. These principles have been tried and tested, and if you go into the industry, everyone's doing the same thing. But now we can revisit that and come up with things that make it much easier for teams to work on, but also for the agencies and the services that are being delivered. We can leverage not only the things that we've talked about, but also the additional cloud services as well. So gain the benefit of the different cloud providers and how they actually operate. So yeah, it's really quite an exciting change.
Actually, that's true. Because just to add on to Hunter's point on, because traditionally when we are on-prem, okay, what we used to do is, or still doing sometimes, is to manually really go and configure the server level kind of configurations, and even the software part we have to manually install and then configure. So with this trend to move to cloud, we are looking at automating as much as possible, so that we can move up the line of innovation also to it's not just for ourselves, it's also for our government and also agencies to really focus on developing values to citizens. Without to really having to worry about the underlying platforms which the applications are running on.
So we're looking at different techniques like DevOps, DevSecOps, automating all our operations to maintain and secure all our platforms. Any technologies are there any cloud technologies that we're looking at, or maybe automation technologies to enable the refreshing of our platforms?
So the team is, at least for the Nectar team, we are looking at building a container hosting platform in the cloud. Okay, and how we are doing that, or how we are planning to do that, is to come up with a set of IAC templates. Okay, to allow developers to better integrate with the cloud native services.
Okay.
Yes.
Okay.
Just to add on to this, so basically from my thought is that on the cloud itself, we can avoid hitting roadblocks based on resources because it's much easier to scale compared to on-prem. And also because on-prem actually requires to liaise with the individual vendors, such as the hardware vendors, the middleware vendors, and all these different kind of vendors actually have different kind of setups.
Yep.
They don't really liaise together, I would not say seamlessly.
They don't integrate seamlessly.
Yeah.
Okay.
So in this case, because on the cloud, you just have to interface with one layer, which is basically the platform.
Yep.
And with this, it's much easier to integrate rather than helping the vendors to seamlessly integrate themselves, and then we need to integrate on top of them again, which reduce a lot of, I would say, technical issues. Yeah. And on container stack, the goal is actually quite similar to Nectar, just that the approach is totally different, which is what you just mentioned, that integration with the cloud is much more seamless.
Can you tell us more about the container stack? What technology are you looking at? What's the makeup?
So the core technology is Kubernetes, which is a very well-known container hosting technology.
Yeah.
So this technology enables us to actually perform a lot of scaling, high availability, monitoring, and actually it's a lot of plugins and enhancement available on Kubernetes, which we are going to make use of. So for example, the integration that Yok Mei just mentioned is actually the operator portion, which we're actually looking into making use of operators, which is relatively new in terms of Kubernetes, which is not available when Nectar was born. So this technology allows us to actually think how do we actually enable integration better.
Okay.
So to add on that, Yok Mei is talking about the configuration and all this. So for us, we also do like IAC infrastructure as code.
Yeah.
So we try to like codify everything so that like for operation wise and all this, it's easier to manage the code and also create new resources. Like cause for like we need to like spin out new resources and all this, so it will be easier and everything is like codified instead of like documentation, which is like more easier to explain. Like code will like just do everything for you instead of like you have to manually do all the steps one by one.
So we're exploring different technologies and techniques to do our automation. What's the envisioned use of SHIP to run all this automation?
Normally, like what we do, like we try to do like CloudFormation, packerize all the configuration inside. So whenever we want to spin out new resources or we want to do some updates and all this, so we just like change the code inside, then we just update in like AWS, then it will just update all the resources straight away.
So SHIP enables the usage of immutable infrastructure and also does automation to execute the IAC to update all the running machines.
Yeah, yes.
Okay, cool. What do we like about Kubernetes? Why do we talk about it so much?
It's the industrial de facto for containers, I would say.
Surely we're more clever than that. Why did we choose it in the first place?
Why do we choose in the first place? First of all, it's very widely supported.
Okay.
And there's a lot of resources out there. It's open source. And the thing is, Kubernetes as a platform, one person cannot cover everything because it's very
very cross-cutting.
Yes.
There's the operations part of it. There's the infra part of it.
There's
the application part
there's
of it.
add-ons.
Sure.
But that is also the allure to it because it's so wide-reaching, it's so feature-rich that you can actually just use it for anything you can think of in terms of hosting platform. As in terms of a hosting container. Which, I will not say that it's the answer to everything. Because there's definitely ways, like for example, there's no such thing as building pipeline within Kubernetes. You need to build your own pipeline. You need to install another product inside Kubernetes to build.
Not yet, anyway.
Yeah, that's why we have different products to handle these kind of things.
Okay.
And as a hosting platform, I believe it's actually robust and long ready for production. We have been using Kubernetes for Nectar also, and we are quite happy with it. But the only thing is that because it is so rich, so powerful, sometimes it's difficult to get in-depth knowledge. Yeah, which is why we want to try to have a platform to help developers get on board without them having headaches.
Sure.
Yeah.
But I think the interesting thing with Kubernetes is that there's a very strong delineation that you can have between the platform operators and the application developers. And so, you can have a team that focuses primarily just on the platform. Now, some of that you can outsource to, the Kubernetes managed service providers in the cloud. But there's still an element of that configuration. So you talk about operators and you talk about various things that are for the platform. But then there's all of the things that live on top of the platform. And so you can have a very strong separation. So let the app teams work on applications, let the operations team improve the platform itself.
Yes.
And so, it's an important kind of separation there. And, I think Kubernetes itself, the reason why it exists is it solves real problems that people are dealing with. Running applications reliably, highly available, fixes things when they go down, reports metrics, so then you can start to get a better insight into the things that you're running. And you're right, I think it's not one size fits all. There are things that you wouldn't run it for your blog or your small web app, but as you start getting into scale, it's a really great consistency. And as we look at using different cloud providers, it's a consistent interface across all of them. And so it lets certainly our teams look at how we can offer the best service based on where an agency would like to deploy their application. So. Really sort of great opportunities, and it interfaces really nicely with, CI/CD tools. And so this kind of workflow works for, the largest end and, multi-tenancy. So there's kind of a lot of different benefits that I think we've realized as part of that.
I think if you want to talk about the benefits, you need to Google
It's
the
never
whole.
ending.
There's a lot of things, but the thing is, mostly is for, like what Hunter mentioned, the whole HA reliability and the the elasticity,
Okay. Yeah. The
scaling part. Yeah.
the conservation of resources or allocation of resources.
Yes.
Right. Anybody has anything to add on DevSecOps? Any other practices?
I think the practices that we're looking at across the different platforms is a really important step. I mean, we've gone into the cloud. We're now starting to get our feet and understand how we're using it. But as we have stable platforms, we can start to really focus on how we're actually delivering. So, we talk about DevOps, which is, it can be a little bit confused with technology, but it's a bunch of processes and things around that you build into the organization. But where it kind of the rubber hits the road is really sort of when you start looking at teams like Ship or Container Stack, where you start to say, well, how do we make sure we're delivering best practice to help enable delivery and making, to be able to enable this across the government for delivery. So we're talking about, DevOps processes around how we're doing, say, testing or deployment, continuous delivery, and the process of, say, deploying to master and how we actually do these sorts of deployment steps. But then we can also start to layer on, which is, an incredibly important part of government is the sort of security and the policy and compliance. So looking at it around testing code security, how to make sure that we start to deliver things that are verified all the way through so that we're kind of having a secure software supply chain, if you will. So, there's these really interesting opportunities because, the government, in the scale of the government, there's an incredible amount of diversity from, different agencies and different requirements. And so, handling those sorts of cases it makes it, very, very important that we understand who we're delivering for, but also building out a flexible way of actually managing these deployments. So, great challenge. And I think it's in having discussions with everyone in the different teams is, everyone's really actively thinking about these sorts of things and coming up with, innovative solutions, ways that we can actually make sure that, what we're doing is actually in some ways, best of class. We're if you talk about the, big technology companies, we're doing the same sorts of things. It's really quite exciting.
we were talking about container stack, right? How does container stack help the developer deploy his application in government environment?
Actually, this should start from ship because the pipeline helps a lot.
Yeah.
Okay, sure.
But then do we talk about Git Ops in that context?
Okay, so there's two parts to it. One part is how the image gets created, which is part of the ship pipeline.
Yeah.
And from there on is the Git Ops pipeline.
Yeah.
Yeah, still ship. Yeah, that's why it's still ship. Yeah.
Okay,
So ship is very important.
So Jennifer, can you tell us about Git Ops with relation to ship? How does ship enable Git Ops?
Yeah, so for ship, I mean, we also do, because normally we do all the codes. Then after that, you have to build. Then we use test. For test, why we also use for GDA, we also got another teams which help in the testing part. Then after that, we do scan for libraries using Nexus. So we check for all the vulnerabilities, like whether the Java is up to date, or whether for your Linux system is up to date. Maybe sometimes the APIs are using the older libraries, so we have to update them so that it's more secure. So normally we'll do the scan, then after that we will deploy to all the different environments. Yeah.
So, I mean, I think we sort of, in discussions with the container stack team, we talk about Git Ops as a way of managing deployments because it shifts everything as left as possible.
Yes.
What are your thoughts on sort of how you go about doing that in a container platform?
So like what she mentioned about the whole ship pipeline actually enable us to build the container, the image, more efficiently and more, let's say, securely, which helps in development, which is what we're trying to help the developers do. So this pipeline enables the whole code to image flow. And from the image, container stack will actually pull the definition files from another Git repo, which is purely definition. So the developer only needs to know what to deploy and what to create in the hosting platform. And this enables the developer to focus on just purely development. And definition will be just consumed by the container stack platform and pull the image from what the ship have built. This is like integration between container stack and ship. Yeah.
So let me just break that down a little bit more. I, developer, I write a bunch of code that is ready to be packaged into an image. Before it's built into an image, there is a CI/CD testing. So we build the image and we test it and scan it and do all the static code scans, and all those reports are put into a pull request of some sort. One of my master developers, he approves the pull request and it gets marked as the latest image.
Yes.
I create another Git repo.
We will create the Git repo for you.
Oh, that's new. Okay. So you create the Git repo with all the definitions. As part of the container stack flow.
Yes.
And I put my definitions in there to mark what my Kubernetes services are. And after that, your Kubernetes container stack will pick it up and deploy the service.
Yes. And during the process, right, we'll actually validate. For example, we'll be using certain policy as code to figure out if you actually have the deployment or have the configuration right. So to avoid security issues, to avoid, let's say, configuration issues, which will actually have two gateways. One is the prevention and one is the alert. We still have not figured out which one should we actually totally prevent or which one should we just let them know that it should be done better. So it's still in progress, yeah.
So at every step of the way, I have checks and balances to make sure that my application is not something that will compromise other government systems. And it is working as intended, all my function tests and everything. And for the deployment part, I also have checks and balances to make sure that my application doesn't compromise the hosting system, and there's nothing wrong with the configuration as well.
Yes. Actually, there's two parts. One is this is the Git Ops model, which is basically definition as code, everything as code. The pipeline, there's actually another environment for the whole pipeline model, which is from ship directly to the hosting. This is for the development stage, where you can actually explore how it will work in the development stage first.
So there's a more forgiving development phase.
Yes.
And then there's a production phase where everything is guarded.
Yes, that is a more controlled environment.
I think there's a really interesting point that was touched on as part of that is that, everything gets put into a pull request. So, the traditional model of doing deployment is that you go and you chase up to your manager and say, hey, can you put this into production for me? Click the button or whatever it is.
Yeah.
Where, if everything goes into the pull request and you're able to see that your security checks passed, your various different builds worked, and everything's actually really good in your development flow, then you both have this kind of really strong audit log, and then as a group of developers and managers and security teams and everything else, you have a single view that you can kind of say, hey, cool, everything looks really good, let's merge this, and then it gets pushed into either development or into production. And so it kind of changes the model in a really interesting way, and I think it's interesting seeing how this kind of adoption is changing in the industry, where typically there's a very, very strong process and very, very strong gating. And it's changing the model so that, again, you move everything kind of closer to the start, that shift left. Everything becomes an easy process that you can kind of look through and pass off to different teams to, get approval of your code merge. And, with everything as code, as we talked about, then this thing makes it kind of like this a common process that works across a lot of different flows, be it Terraform, CloudFormation, Kubernetes, or even API gateways. And I think that, there's a really interesting exploration as we start adopting the cloud in more detail and sort of taking on these really interesting new modern processes to actually improve the agility of deployment and stuff. It's really quite exciting stuff.
Yeah, so like for what you say, like for manager, whenever they want to approve something, because they will be worried whether this artifact is actually the one we tested or is it the actual one that we need to deploy to production? Because like some of them will be afraid like it will be the wrong artifact or it's the old one. So normally for our pipeline, because we will be like taking from the same artifact from the same repo, so it will like be built to like dev. Then after that, the same repo will go to build dev, then to UAT and production. So it will be definitely it will be the correct artifact. It won't be like suddenly when you go to production, then the next day there's production failure because they deploy the wrong artifact.
And the definition is always source
Consistent.
control and there's versionings. So there's no need for example, missing versions in the between where nobody knows what is happening. It's visible and transparent.
Yeah, and you can keep track like what is the changes between the previous and the latest artifacts.
Yeah, it kind of lends itself to a really interesting sort of view of where the next stages are going as you get past that is sort of saying, well, look, I know that I've got the right image, but, how do I know that that image is going to go all the way through and get into production in exactly the same way? And now we have kind of signing and cryptography to know that these things are kind of legitimate, but then how do you know that you've got this kind of end-to-end stage to say, the developer who wrote the code and checked it in is the same code that got into the repository, and then the image that got built. And then so you can kind of build on that to have this really kind of strong end-to-end secure process so that when it hits the workflow at the end, the Kubernetes cluster can kind of say, I can see that there's all of this kind of, cryptography and signing that says everything's cool, I'm going to let it in. Versus the current model where it's sort of like, well, we kind of trust that this stuff is going in there, and this is really cutting edge stuff in the industry that not a lot of organizations have started to adopt. So it's really quite exciting. I mean, I know we've had discussions in the groups about how we start to have this kind of end-to-end security, tying together the metadata for this secure delivery pipeline, and this sort of things that we're kind of exploring. What is now the cutting edge of software deployment is. It's really great to see that teams are really starting to think about this stuff.
Which can be controlled by using the policy as code. Which is quite fun to... Actually, this is the first time I'm actually touching on policy as code.
Okay.
And throughout the journey, quite amazing.
Amazing. How
Yes,
so?
because it's like normally you think about doing configuration rather than doing it in code. You'll be configuring such that you only whitelist certain repository.
Yeah, okay.
Which is actually, let's say, restricting in terms of if you need to whitelist another repository, you need to go through the firewall, you need to find out the IPs, you need to find out domains, all this stuff. But with policy as code, it's basically just a definition on which, let's say, when you deploy something, which image source do you allow them to come from? Yeah, which is pretty straightforward. and
So-
quite a learning journey.
Just to contrast, before we make any changes in production, you have to get the approval of 5 or 6 people manually and go through with them what your changes entail. And the most frustrating part about that is you have to describe in ridiculous detail what you're doing and what implications it has. With policy as code, you can still code anything you like, but the policy as code will catch you and then tell you no.
The policy as code part is basically the one that define what you can do.
Okay.
But the ship pipeline is the one that actually define what changes is happening.
Okay.
So as a manager, you want to know the changes and you want to know what impacts.
Okay.
Yeah, so the impact actually is listed out during the test cases, during the scans, so you can see the differences.
So what you're saying is inside the Git Ops, the pull request, because of the Git Ops process, the delivery pipeline, you get a summary of all the changes about to be made. So you still get your manual process, your manual approval process.
Pull request, yes.
Yeah. And when I think your policy as code also catches it at that stage.
2 stages, yes. Can we consider that?
And
Yes.
even if they approve it, even though it doesn't pass the policy as code check, the final stage in production it's caught
Yes.
and it's still not deployed because of
Yes.
that. Okay. So throughout the entire
Multi-leaf.
process, there is assurance that you don't do
Something naughty.
Something naughty.
Right.
It's called defense in depth.
Yes, defense in there.
But the thing is okay. So recently I went for this IAC, is it the IAC seminar or session, which actually taught us about you cannot actually catch everything in one place. You actually need to have a Swiss cheese model, they call it.
The Swiss cheese model.
Yes.
Sounds
Yeah.
tasty.
Yeah.
Is it grilled cheese or is it not?
So basically, there's bubbles and gaps in between a layer, and there's multiple layers to catch different kind of things. Yeah. So throughout the pipeline, throughout the hosting platform, throughout the whole tech stack, there should be different ways to catch
Different tools and different ways to catch
possible issues coming up. Yeah.
possible issues. Yeah. The right tool for the right job, right?
Yes.
You can only have one tool for catching wrong infrastructure as code. You can only have one tool for catching wrong code. To have full assurance, you need to have a series of checks and make sure they all pass. Yeah.
Yes.
Yeah, good. So this series of platforms is part of the Singapore tech stack. Is there anything new for the Singapore tech stack? What's being planned for the Singapore tech stack?
Actually, the something that is brewing, which is what Isa mentioned just now on container stack. Okay, this one is another the next generation of container hosting because we are now moving into GCC. So the intent of this new container hosting system is slightly different because we aim to achieve the level of abstraction layer above the government commercial cloud, so that we are not there to solve world hunger. Okay, let's put it this way. Okay, but we are trying to enable this container stack to shield users from the underlying complexities on the runtime platform. Okay, so they can really just focus on developing applications.
So I can develop my app, package it into a container, throw it in the container stack.
Right.
It's in the cloud, already running.
Yes.
Yes.
And it's being continuously built and delivered by Ship.
Yes.
And all my
So,
APIs are being passed through Apex.
correct.
So there's
That is
one
the-
important thing that's missing out of all of that though, which is coming as part of the tech stack is the operations piece. I mean, how do you keep these things? How do you deliver reliable applications once you've deployed them? Now you can with things like Ship and Container Stack, you can deliver very quickly when you find a bug or a problem. But if those services go down, how do you know? So as part of that, in looking at the operation side, delivering things like site reliability engineering, strong operations and log monitoring metrics, kind of then adds that layer of maturity on top of it to say that we're delivering both high quality and secure software, but it's also running reliably so that it doesn't go down when there's a big spike or
Right.
there's a problem that knocks it offline. We can solve it very, very quickly, or at the end of the day, hopefully no one notices and everyone can actually have a working service for whatever we're building.
Oh, as a government agency, I want my service to be running all the time. So that sounds really useful.
Yeah.
I'm going to open this. Let's see, what's the last question we have? Okay, not that question.
Now I want to know what's
Something
the
a bit more
question.
lighthearted, right?
Oh,
No.
Sounds
It's
very
more
serious.
That's a long one. I thought the
Wow.
other one was a shorter one.
I love this. This is great, actually.
Now I want to know what's that question.
yeah.
If you had a HUD, heads-up display, that showed 3 stats about any person you looked at, what 3 stats you would want it to show?
Stats as in STATS?
STATS.
Statistics.
It's a bit sensitive.
Okay. That means...
For example.
Actually,
How grumpy they were today.
Oh yeah, actually that's
Yeah.
pretty useful.
recently I was talking to my ex-colleague about EGG monitoring.
EGG.
Basically
model.
the brainwave monitoring.
Oh.
Yeah, and I was just talking to them that it's not mature enough to actually cater for the masses because everyone brainwave is different. So in this aspect, right? Okay, I'm talking. I'm thinking too technical.
If you had a magic device, oh,
It sounds like a superpower.
Yeah, it's
It
not
is a
about.
Yeah.
That suddenly reminds me of X-Men, you know.
Yeah, it's like, yeah. But it could be used for good or evil.
Okay, this is where I let my geek out. Have you guys watched Death Note before?
Uh-huh.
Oh, yes.
So where you look at people and you
can
see
see all
the
the-
Life expectancy.
the number of years left in their life. Would that be of use to you?
That's
I
pretty
don't know.
scary if you ask me. I wouldn't want to know
Yeah.
about this.
So
It's
if
a little dark.
any other statistic, a mood level meter is great.
Yeah,
If-
mood level meter, happy, sad. You know, the question is, do you use it for your advantage or do you use it?
Yeah, especially just before steering comms.
Yeah.
Oh my god. We need that for steering comp. Yes.
Yes.
Yep.
I read a lot of science fiction books. There is this situation where if you can detect the mood of a person, you can use it to your advantage because you know whether the guy is lying or not,
Yeah.
or whether he's committed to your cause or not.
Yeah.
And with that kind of information, you can convince him of all the things you want him to do.
Oh, that's very evil of you.
So I guess mood level is a great example.
Yeah.
Let me see.
Stats.
What stats would be useful in your everyday life?
Hunger level.
You've been playing a lot of Sims, haven't you?
Useful.
It's an indication.
Sleepy-
Hey
sleepiness.
guys.
Oh, stupid. All these affect the mood.
Yeah, we kind of get that when they actually fall asleep at the table, though. So that's fine.
Yeah, I think the mood level is actually the most useful.
Yes.
Yeah.
Yep.
I can't think of anything because everything is related to mood.
Yeah. Indirectly or directly.
Happy, sad,
Yes.
nervousness. What else is there?
If it's not related,
Excitedness, I guess.
that one is all mood. If it's not really like, for example, the feeling space is like heart rate, which is
yeah,
what
yeah,
all
yeah,
the
yeah,
all the smart watches have already, which is possible.
That's kind of like a
that is-
remote polygraph, isn't it?
But
In a
that
way,
is
yeah. The question is, if everyone had it, would it be allowed though? Would you want somebody to be able
The
to
question
read
says
your?
you.
No, I know, but it opens that
wouldn't.
kind of interesting question of would you want other people to be able to tell those things? If you both had it, is that equal?
Yeah,
Then you can do
that's
it.
kind of freakier.
Yeah.
no. I actually think that it will be useful if it's actually let's say location based. No, location based.
Location
For example,
based.
in a hospital,
Uh-huh.
if you are a patient, if you actually have this kind of statistic up,
Yeah.
it
Heart
helps.
rate, blood
They
pressure.
got that
Yeah.
So if I have this HUD, I can
For the
look at
doctors,
people's
Yeah.
statistics.
For the nurse,
Yeah.
yeah.
Yeah, that'd be useful.
Yeah, I think that's
Yeah.
I think that's where a really great potential of things like augmented reality is. You know, you have like a hospital, you're able to see diagnostics without necessarily having to go and check something. Same as repairing equipment. Being able to see what's that part. What do I need to do to fix it? Calling up these sorts of things. But yeah, I mean the question of understanding it about another person is a little bit more of a grey area.
Or psychologists, if you want the feelings part.
Exactly.
Yeah.
Yeah.
What are the type of people we're looking for to help us build these technologies, these platforms? people like you?
A lot of criteria though.
It's a very generic question. Depends on which angle you come from. Okay. My personal feel, top of my head, is I personally feel there should be gender diversity in technology.
For sure.
Women in a technical team has proven to have more social sensitivity to the whole team, and then I also do believe in a collaborative kind of team intelligence. Okay, so with usually, research have also shown that with women in a team is supposed to boost productivity, work productivity.
Okay, all right. Yeah. It's important to qualify that. Okay. Thank you for clarifying that.
That's my take.
Any other criteria?
Actually, one of the main criteria is basically the enthusiasm to actually push things forward, because technology moves very fast.
Yeah,
you cannot catch on. But that's why you must have the drive to keep learning things. That is the emotional part. So the technical side of things, because this kind of platform that we are actually driving to create requires a lot of deep thinking. Not just go inside and code, not just go inside and use whatever that is. It's about thinking about how do we, let's say, integrate with each other. For example, there's different products and we are part of the SG tech stack. So we must think of how do we actually work together with each other.
Okay.
How each technology complements each other.
So there's a fair bit of understanding the technologies, and not just your team, but other people's as well, other teams as well, and trying to plan for that future integration.
Yes.
So that takes a lot of foreplanning,
Yes.
foreshadowing, foreplanning. Yeah.
For me, I think other than skills, it will be like people who are willing to learn, because over here we really learn a lot of things, like all the different technologies, like I can understand what the other teams are doing and other projects, and also innovative, and also people who like to help the governments and help the citizens, civilians.
I think that's a really important point, is understanding who you're delivering for. It's really, really easy as engineers that we kind of go, yeah, cool, there's a cool piece of technology, let's go and use that, without sort of saying, well, hold on, let's step back a little bit and say, is it actually going to do the things we want to do?
Right.
But I think that's always a really important pool. And it doesn't mean you don't necessarily like doing cool tech, but there certainly is that kind of curiosity that you need to know what's available, but also, how people are going to be using it, because if you're not solving the problem. But, I always find something interesting, and it'd be kind of cool to get what you think is it better to have a team of really kind of broad people who kind of understand a lot of stuff, or like really, really strong specialists? I think, it's always an interesting question to pose. What makes a good team?
There's always pros and cons to both sides.
Yeah, of course.
You?
Me?
Yeah.
Don't just skip the question.
Okay, fine. I pride myself as a software engineer. I do place a lot of importance on technical ability. But like you said, I do believe that the drive to learn, you must always be willing to try new things. I have interviewed people who are really masters of the craft, supreme Java developers. But they're not what we're looking for, because we refuse to look at anything else other than Java. Same thing for Python, same thing for PHP, C++, Node.js. If you are stuck in one technology, you're not going to last for long, because the technology moves very quickly. So the kind of people that we're looking for, those people who are willing to learn new things, people who are willing to adapt, and most importantly, people with tenacity. I think working in government takes a lot of dedication, really, because it's like working in an enterprise. You have so many security policies and other policies you also need to follow, and you need to be able to work with all the constraints that you're given. Tenacity. That's what I look for.
I think it's the tenacity is an important part of it, but ultimately the goal at the end of it is actually really, really rewarding as well.
Yeah.
You know, it's actually having a much bigger impact than it may be in a general enterprise, which is kind of cool, right?
To actually want to work for government, I think you need to have a bit of civic mindedness, right? You want to, you want a better country. You want to enable the citizens to do anything with their data, with their applications. You want to be able to enable agencies to engage the citizens better. You know, you want it to go the other way as well. You want the citizens to reach the agencies easily as well. To have that vision and doing whatever you can to achieve that. I think that's also important. Right?
Yeah.
I mean, there's a reason why I'm stuck in GovTech for about 5 years. About as old as I am. I mean,
Yes.
Yeah, I'm the relatively newbie here, I think.
She's probably the newest.
we need fresh blood.
Especially-
We always need fresh blood, and we need fresh insights. You know,
Yeah.
What we've seen with Hunter is you've given us insights on how to use cloud, how to use the new technologies, and also how to better design our systems for reliability, how to better design our systems for automation. You know, without that, I think it's one thing to just look at what everyone else is doing and saying, oh, we should do that. It's another to translate that to business value, right? Yes, that looks cool, but how does it actually relate to your operations? You know, how does it save you 5 to 10 hours of work every time someone wants to onboard into your platform? You know, how does it save me 10 hours of work when I try to deliver a government service, or maybe 200 hours of work?
And also to tackle problems from a different view.
Yeah.
Yeah, because normally when we look at a problem, as an engineer, I would just say, build something to solve this problem. But it's better to look into what is available outside and making use of them. Yeah.
Are you saying that I cause trouble and ask the inconvenient questions?
No,
or-
no. Not
He's
overtly, no.
You can be honest about it if you want. You guys go home and say, damn that guy, he's...
We will talk after, behind this.
Yeah. I can step out of the room if you want.
To that, I think it's not just about hiring engineers. We also need a lot of different people of different expertise. Let's not forget the designers who conduct really interesting user design experiments. You know, they actually, before we even start building a service, they actually conduct research to say, do you even really need this service? Do you really need to build a
Actually,
mobile
that's very
app for
important.
that?
Yes, that's very important because as engineers, right, we have this tendency to to come up with some solutions that we think should work for the mass, but unfortunately or fortunately, sometimes it doesn't work that way. So we do really need to understand what the users are really looking for. Okay, and then in order for us to build usable systems. So that point on UI UX designers is very important.
They also help make our applications look good. Our
Yes.
services. Yeah.
Yes.
I think it's an important point, though. Sort of raising the question of, well, in most organizations, how it's been traditionally, which is kind of why we talk about transformation, is there's been these very strong silos. You've got a development team,
Right.
you've got an operations team, you've got a design team, and a very, very important part of how we try and make things better and enable better delivery, building better products, is working together. And I think that's a really important part of how we're starting to look at working through these things. And it's interesting, is sort of, you say, well, is it a change that needs to come into the organization first, or is it coming from other things? Or is it the use of cloud that's going to change us coming backwards? And I think there's not one answer to it. But it's kind of cool to see that these sorts of pull in different directions, ultimately is to really serve to actually make Singapore better, but also deliver important products that make these things happen.
Actually, I think that it's more of a wave. It's like there's always ups and there's always down. Like how initially before GovTech IDA, it's more vendor management and less engineering. And we actually outsource the engineering to the vendors. And now we are transitioning to the engineering part. But I believe that it's not actually
It's not constantly.
it's not a constant thing. Yes.
We can't possibly engineer in-house everything.
Yes.
There are certain systems that we need to outsource, especially what we look at within GDS is whole government concerns. But there are so many agencies with so many services that they need to build.
And so
we
many
can't
different
possibly
kind
work on all
Use
of them.
cases
So many
as
different
well.
kind of capabilities.
Yes.
Yes, and we need to cover everything, but we can't cover everything.
No, we can't.
Yeah.
So we need a lot of people. Other than that, project managers, agile experts. What are the kind of other expertises do we need?
Actually, one of the role which is quite let's say not in the limelight is the technical writer.
Very true. Yeah.
Yeah. Actually, they are the one who actually convert us engineers talk in tech terms. Which
I thought you said that IAC solves all of this stuff. We don't have to write documentation anymore.
no, documentation is internally, as in this kind of documentation is more for like internal use for us to reference.
For the
But
developers.
for the public, for the users, for the tenants,
Yeah.
they need to have another understanding.
Yes.
So technical writers help us to convert what we wish to let them know.
Very true.
Yeah.
Yes.
I think it's really, really important and something that's actually overlooked a lot.
Thank you for watching this episode of Techaway. Do tell us what you think of our strategy and our platforms. Please do leave your critiques and feedback in the comments.
Less critics, please.
Less critiques, please. Do suggest any topics you want to learn about in the comments as well. Subscribe, like, and do share this video with your friends. Thank you for watching.